I'm tackling a machine learning problem involving a dataset. The data's a bit messy, features have different scales, and the data isn't normally distributed. To fix this, I'm using a technique called the Yo-Johnson transformation, which is part of the scikit-learn library in Python. This is a multiple-choice question testing my understanding of the Yo-Johnson transformation as implemented in the _power_transform function within the scikit-learn library. The function is used to transform data, potentially making it easier to analyze or use with machine learning algorithms. This statement checks whether the Yo-Johnson transformation can only work with positive numbers. I need to remember what characterizes this transformation. This option tests my understanding of whether the Yo-Johnson transformation can handle data with both positive and negative values. This option checks if the goal of using the Yo-Johnson transformation is to make my data follow a normal distribution. Many statistical techniques work best with normally distributed data. This option asks whether the Yo-Johnson transformation changes the order of the data points after performing the transformation. The relative sizes of the data points, I must remember, might change. This question tests your knowledge of the Yo-Johnson transformation, a powerful tool in the scikit-learn library used to prepare data for machine learning models. We'll analyze each statement to see if it accurately reflects how Yo-Johnson works. Let's dive in. This statement is FALSE. The Yo-Johnson transformation is a supercharged version of the Box-Cox transformation, which does require only positive numbers. However, Yo-Johnson is designed to handle both positive and negative values, making it more versatile. So, this isn't correct. I would say this statement is true. That's precisely the beauty of the Yo-Johnson transformation. It's designed to overcome the limitations of the Box-Cox transformation and work with a wider range of data, including negative values. That's a key feature. Yep, this is true. We often use transformations like Yo-Johnson to make our data look more like a bell curve, normal distribution. Many statistical models perform better with normally distributed data, and this transformation helps us achieve that goal. That's a crucial point. And this statement is also true. While Yo-Johnson changes the scale and distribution, it generally preserves the relative order. A large value will still generally be larger than a small value, even after the transformation. It's like rearranging the furniture in a room. The basic layout remains similar. This is a quiz testing your knowledge of the Yo-Johnson transformation, a statistical technique used to change data's distribution. I'll ask you questions about its properties and how it's used. That's incorrect. The Yo-Johnson transformation is actually designed to work with both positive and negative numbers. It's a more flexible version of the Box-Cox transformation, which only works with positive data. This is absolutely correct. The Yo-Johnson transformation is specifically built to handle datasets containing both positive and negative values, unlike its predecessor, the Box-Cox transformation. You got it. A major goal of transformations like the Yo-Johnson is to make your data closer to a normal distribution. Many statistical models work best when the data fits this pattern. That's right. Even though Yo-Johnson changes the spread and shape of the data, the relative order of your data points will usually stay the same. A large value will still be larger than a smaller value, even after the transformation. This is the specific type of transformation being discussed. It's a mathematical function that changes data values to improve the data's distribution. This summarizes a key advantage of the Yo-Johnson transformation. Unlike some older transformations, this one can handle numbers greater than, equal to, or less than 0. This highlights the transformation's objective. I'm aiming to achieve a bell-shaped data distribution, making it easier to use with various statistical models and machine learning algorithms. This describes the transformation's effect on ranking. The order of the data, from smallest to largest, is typically maintained after applying the Yo-Johnson transformation. I'm focusing on the Yo-Johnson transformation, a powerful tool in scikit-learn for data preprocessing. It's a type of power transformation, meaning it changes the scale of your data to improve its properties for machine learning models. We have a dataset with features having different scales and distributions that aren't normal. To fix this, we'll use the Yo-Johnson transformation. This statement is true. The Yo-Johnson transformation is awesome because it can work with data that includes both positive and negative values, unlike some other transformations. That's right. Absolutely true. A key goal of the Yo-Johnson transformation, and power transformations in general, is to make your data look more like a normal distribution. Many statistical models work best with normally distributed data. This is also true. Although the transformation changes the values, it generally keeps the relative order of your data points. If one data point was larger than another before the transformation, it will likely still be larger after. This one is false. Remember that the Yo-Johnson method is designed to handle both positive and negative values. I'm asking you to identify the correct statements about the Yo-Johnson transformation, a method in scikit-learn to change the scale of data. We'll focus on its properties and how it affects data. Let's get started. This statement is true. The Yo-Johnson transformation is awesome because it can work with all kinds of numbers, positive, negative, or zero. It's different from some other similar transformations, which only work with positive numbers. That's true. The main goal of the Yo-Johnson transformation and similar techniques is to make data fit a normal distribution, a bell-shaped curve, which helps many statistical models work better. This makes the data easier to work with for many machine learning algorithms. This is also true. Even though the Yo-Johnson transformation changes the values, it keeps the data points in the same order. If one value was bigger than another before the transformation, it will still be bigger afterward. This statement is false. Remember, the Yo-Johnson transformation handles both positive and negative numbers, so this statement is incorrect. This question tests your understanding of the Yo-Johnson transformation, a powerful tool in scikit-learn for data preprocessing. I'll guide you through each statement to help you select the correct ones. This statement is false. The Yo-Johnson transformation is specifically designed to handle both positive and negative data. Unlike the Box-Cox transformation, which requires strictly positive values, this is true. That's a key feature of the Yo-Johnson transformation. It's a generalization of the Box-Cox transformation, extending its capabilities to accommodate data with both positive and negative values. Correct. The main purpose of the Yo-Johnson transformation, and other power transformations, is to normalize your data. This is crucial because many statistical models and machine learning algorithms assume normality. This is also true. While the Yo-Johnson transformation changes the scale and distribution, it maintains the relative order of your data points. Larger values will remain larger than smaller values, even after transformation. This is the title of the quiz focusing on applying the Yo-Johnson transformation. This phrase simply describes the topic of the quiz: how to use the Yo-Johnson transformation to modify data. This describes the kind of data you would typically apply the Yo-Johnson transformation to. Datasets with inconsistent scales. Some features range from 0 to 1, others from 0 to 1000, and non-normal distributions. Data not following a bell curve. This specifies the method used for transforming the data. Scikit-learn's _power_transform function provides a way to easily apply the Yo-Johnson transformation. This describes the expected output after applying the transformation. The data will have a more normal distribution, but the relative order will be preserved.